Okay, we're doing Chapter 9, Quadratic Equations. This is Chapter 9.2, which is the Quadratic Formula. So the Quadratic Formula was derived from the standard form, ax squared plus bx plus c equals 0. And you want to solve for the variable, which is x in this case. And what they did is they took this form, no numbers, and completed the square and came up with the quadratic formula. If you want to see how it's derived, you can take a look at page 557 and walk through all of that. Makes it very interesting. But basically, the quadratic formula is a way to solve these quadratic equations without factoring, without completing the square. It's a third method. A third method to solve quadratic equations. Now remember what solving for x means. It means finding the values of x that make the equation true. So the quadratic formula, okay, the solutions of ax squared plus bx plus c equals 0. I'm utilizing these locations a and b and c, a, b, and c, where a does not equal 0, because if it did, then this wouldn't work, because then it would be a linear and it would be a lot easier. And we need this because we're going to have a in the denominator. Are given by x equals negative b plus or minus radical b squared minus 4 times a times c. That entire value, including the negative b, is over 2a. So my denominator has an a in it. That's why a cannot equal 0. Otherwise, it doesn't work. Remember, this is two solutions. Negative b minus radical b squared minus 4ac over 2a, and negative b plus radical b squared minus 4ac over 2a. So I have to tell you, the pop goes the weasel. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Yeah, I think it's stupid. I asked you guys to write it 10 times so that you memorize it. You could do the little tune. I don't remember the words to the tune, but I do remember the quadratic formula. If you do it a couple of times, make sure you divide the whole thing by 2a. Or both of them by 2a. Keep them separate, but give it to both. Let's see here for a minute. So let's give you anything. Let's solve. Let's start here. Procedure for solving a quadratic equation. There are 3 ways we can solve it. One, I guess the cleanest way is try to factor the non-zero side. And then after you do that, you're going to use the zero factor property. Split the factors and set them both equal to 0. Okay? 2, you have a choice. You can, give me a minute. You can complete the square. And then use the square root property. Some equations are already set up to use the square root property. Go ahead and use it. It's your best bet. Go ahead and use it. One thing I want to point out here, when you're factoring, not all equations can be factored. That's why I say try it. Try it. Then it sometimes works, but sometimes it doesn't. Completing the square will always work, and then use the square root property. If your equation is set up to use the square root property, use the square root property. It's if the square is already completed. That will always work. And also, so both this step 2 will always work. Use the quadratic formula. These both of these will always work. They will always work. If you go ahead and use the quadratic formula and then your square root ends up being nice and you can simplify it and your answers are rational, then you could have factored in the first place. Because this is only this only works with rational roots or rational solutions. This will work with any solutions. This will work for rational solutions, irrational, or even imaginary. I'm sorry, complex. These are the types of solutions. So that's the procedure for solving quadratic equations. You know the whole story. We've done a lot of work with this in chapter 6, and this is what we're really learning in this chapter, 9.1 and 9.2. So let's take a look and play with the quadratic formula. Solve. You want to solve. Let's try this one. 4x squared minus 11x minus 3 equals 0. So we want to use the quadratic formula. Using the quadratic formula. I want to point something out here. If there's a common factor to all of these, meaning of the numbers, go ahead and divide out by it. You will still have an equation with lower numbers and a 0 on the other side. 4, 11, and 3, we don't have anything. So let's first identify what A is, B is, and C is. A is the coefficient of x squared, which is 4. B is the coefficient of x, which is negative 11. Do not forget the sign. And C is the constant, which is negative 3. The variable is x. The solution is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, so let's just plug in a, b, and c into this equation. This is an equation. It's the solutions to x. X equals negative 11 plus or minus the square root negative 11 squared minus 4 times a, which is 4, times c, which is negative 3. That is all over 2 times a. Okay, I'm going to clean it up a little bit. X equals 11 plus or minus the square root. Negative 11 squared, quantity squared, is positive. This value here will always be positive. 121. This here, negative and a negative, I'm going to be adding in here. 4 times 4 times 3, 48. What is 121 plus 48? I end up with square root of 169. And I also recognize that as, did you see what I just did? I raised it to the 1/2 power. So I actually took the square root of the answer. Instead of doing the square root of 169, I just did the answer to the 1/2 power, because the 1/2 power is a square root. There you go, some calculator tricks. Whoops, this is all over 8. So I still got one more thing to do. 11 plus or minus, this right here is 13. 13 over 8. Oh, look at that. 2 answers. X equals 11 minus 13 over 8. And x equals 11 plus 13 over 8. 11 minus 13 is negative 2 over 8 is negative 1/4. I simplified it. This one is 11 plus 13 is 24 over 8, which is 3. So my solutions are supposed to be negative 1/4 and 3. So since these are rational, then I could have factors. It's not too clear as what it is, but if I try to factor it, use factoring, I had 4x squared minus 11x minus 3 equals 0. I get negative 12, and I see that a 1 and a 12 will get me a difference of negative 11. Negative 11, this is negative, this is positive. 4x squared minus 12x plus 1x minus 3 equals 0. 4x, x minus 3 plus 1, x minus 3 equals 0. And this factors to 4x plus 1, x minus 3 equals 0. Zero factor property. 4x plus 1 equals 0, x minus 3 equals 0. This one is x equals 3. Got it. This one is minus 1, 4x equals negative 1. Divide by 4, x equals negative 1/4. So I have the same solutions that I did in this. I could go ahead and do completing the square. It's not going to be too pretty, but it's doable. It's doable. You know what? Let's do it. Use completing the square. That way you see one problem with them all being done. Solve 4x squared minus 11x minus 3 equals 0 by completing the square. You should know how to do all these processes. This doesn't start. I need to divide by a. Divide by 4 across all the terms. So then I end up with x squared minus 11 over 4, x minus 3 over 4 equals 0 over 4, which is just 0. Move this one over to the other side and create a space so I can complete the square. X squared minus 11 over 4, x plus a blank equals, when this one moves over, he's a positive 3/4 plus the same blank. Okay, so I've got to take negative 11/4, divide it by 2, which means I'm kind of multiplying by 2 on the bottom, and then square that. So I get a negative 11/8 squared. That number I'm going to keep there, which I get 121 over 64. So I'm going to add 121 over 64 to both sides. And I see that I need to get common denominator. 64 divided by 4 is 16 times 16 times 16. 16 times 3. This is, 48 plus 121 over 64. I'm getting common denominators, so I can actually add that. You can do it on the calculator if you want. Get it back into a fraction. You probably don't need to, but let's see. So this left-hand side is something. Okay, now I go back here, and I see that this negative 11/8 is going to go right there. Negative 11/8. Negative 11/8. So I end up with x minus 11/8. I told you this one was going to be messy. Equals 48 plus 121 is 169 over 64. Take the square root of both sides. Plus minus. That's not bad. Don't be afraid of that. X minus 11/8 equals plus minus square root of the top, square root of the bottom, 13 over 8. Oh, that's good, because then I'm going to add 11 over 8. Add 11 over 8. And we end up with x equals 11 over 8 plus and minus 13 over 8. But we know that that'll be x equals 11 minus 13 over 8. And x equals 11 plus 13 over 8. This one is negative 2 over 8, which is negative 1/4. And this one is 24 over 8, which is 3. So we get the same answers again, regardless of what method we use. We were able to factor this one, but remember, we can only factor if the answers or the solutions are rational numbers, fractions. So let's take a look and see what happens if we get something that is, let's say, irrational and maybe even complex. So let's do this one. Okay, let's start here. I'm going to do quadratic formula this time. Only the quadratic formula. I'm telling you right now that you're not going to be able to factor these. So we are going to do 2x squared plus 19 equals 14x. Okay, well, we can't know what ABC is until we get it into standard form. So I need to get everything on the same side and put it in order. 2x squared. I'm going to subtract 14x from both sides. This was a plus 14. Subtract 14x. Subtract 14x. So I got a minus 14x plus 19 equals 0. I identify A as 2, B as negative 14, and C as positive 19. Take the extra time to do that. It'll save you some time later on. X equals negative B plus or minus radical B squared minus 4AC all over 2A. Okay, so let's substitute. X equals negative 14 plus or minus square root of negative 14 squared minus 4 times A times C all over 2 times A. We have x equals positive 14 plus or minus the square root negative 14 squared, squared is 196. 196. I look at the signs and I see we're going to be subtracting. 4 times 2 times 19 is 152. All over 4. One more move over here. 14 plus or minus square root. 196 minus 156. 196 minus 156 is 40. So the square root of 40. We'll divide it by 4. Square root of 40. 40 is 4 times 10, which is 2 times 2 times 2 times 5. The square root of 40 is the square root of 2 times 2 times 2 times 5. That comes out as 1, is 2 square root of 10. I'm going to rewrite that on the next shot and split this. X equals 14 over 4 plus or minus 2 radical 10 over 4. And I see that these both have a 2 in it and these both have a 2 in it. So I get 7 over 2 plus or minus radical 10 over 2. Notice how the denominator is rationalized already. And that is my solution for X. I'm checking it right now. I didn't get the right answer. Let me go back and see what I did wrong. Okay, this ends up being 152. So 196 minus 152. Yep, there it is right there. 152 is 44. So that is going to be 2 times, this is going to be an 11. 44 is 4 times 11, which is 2 times 2, which is 2 radical 11. So this is going to be an 11. And I get 7 plus or minus radical 11 over 2. So that is our answer. 7 over 2 plus or minus radical 11 over 2. Okay, one silly little mistake. Didn't work. Let's do another one. Maybe I'll get this one right. I don't have you guys catching me in class. Okay. Let's try. Let's do something a little bit more complicated. Let's solve this one using the quadratic formula. We've got x plus 2 times x minus 6 equals negative 17. I don't even know if it's quadratic at this point, but I do, well, can I set each factor equal to negative 17? No, you can't. So let's kind of clean this up. Let's multiply and then move the 17 over, get it in standard form, and see what we get. X squared minus 6x plus 2x minus 12 equals negative 17. I'm going to add this 17 over here and combine like terms on the same shot. I end up with x squared minus 4x plus 5 equals 0. Yeah, so we've got a equals 1, b equals negative 4, and c equals 5. The solutions to this, the variable x equals negative b plus or minus radical b squared minus 4ac all over 2a. And I actually say this while I'm plugging the numbers in. Negative b, whoops, negative 4, which is actually a positive 4. And notice, regardless if b is positive or negative, this is going to be a positive number. In this case, 16 minus 4 times a times c. All over 2a. So we get x equals 4 plus or minus the square root of 16 minus 20. All over, whoops, 2a. That's silly. 2 times 1, which is just 2. So we get 4 plus or minus the square root of negative 4 over 2. We already saw what the negative 4 was. Take out the I and simplify radical 2. Take out the I. So x equals 4 over 2 plus or minus, I like to split it so I can simplify, 2I over 2. So x equals 2 plus or minus I. Two solutions, 2 plus I and 2 minus I. Those are complex. And we saw an irrational. So how do you know what your solutions will be like? And what do I mean by that? I mean rational, irrational, or even complex. How do you know? Okay, so it all depends on what's under the square root. What's under the square root is known as the discriminant. B squared minus 4AC is called the discriminant. B squared minus 4AC is called the discriminant. So what's under the square root? That's what it all depends on. What's under the square root. So let's look at all the quadratic. Let's look at all the quadratic equations, formulas that we use to solve the quadratic equations. So we had one of these, we had one of these, and we had one of these. So complex, well, let's start here, rational. Let me just pull out my rational example that we just did. Give me a minute. Things all over the place. Here's my factoring. When we factored it, we completed the square. Oh, here it is. Okay, so we had this equation. We did the quadratic formula. We ended up with -1/4 and +3. So what made these radical? There is no radicals. We got to this point, and what was underneath the square root was a perfect square. So that's what gives you a rational solution. So a rational solution means that the discriminant, let's see if I kind of can organize this. The discriminant for a rational is going to be positive and a perfect square. We had positive 169, which was 13. For an irrational, let's take a look at that problem. That was the one that I messed up a little bit. But what's underneath the square root? We had square root of 44, so 44 would be the discriminant. That is positive, but it wasn't a perfect square. So for an irrational number, it's positive, not a perfect square. Because if we take the square root of a perfect square, we get an integer. And complex is with the i's. So basically that's just anything else, negative. Even if it's a negative perfect square, this is a complex solution. There is one more that we haven't seen, but so positive, negative, in between those two is if it's 0. If we get a 0 discriminant, that means our solutions, we have one solution. one rational solution. So if it's 0, you're doing plus or minus 4, like for instance, 4 plus or minus 0 over 2. So this one would only be 2 if it ended up being that. So you only have one rational solution. So those are the ways that this works. So you can just take a look at this, the discriminant, to see the nature of the roots. This is called the nature of the, oh, I said roots and I didn't mean to say roots. That's what it's also called, but it's the nature of the solutions. Okay, we're going to see that later on. So you are all set. You can do the 9.2 homework, and I will see you on the next class.